Bismillahirrahmanirrahim. Welcome to the second part of this topic, which is integration of rational functions by partial fractions. In the first part, we spoke about the first case, which is where the q of x with the denominator is a product of distinct linear factors. And we solved some examples for that case. That if we have q of x is a product of linear or distinct linear factors, where q of x is the denominator of the function. We have f of x equal to v of x divided by q of x. So that was the first case. We have distinct linear factors. This part, we are going to speak about the second case where the q of x is a product of linear factors, some of which are repeated. We have repeated factors. In this case, the q of x or the fractional function will be written as, for that factor, which is, if suppose that we have the first one, a1, x, b1, is repeated. Then we can write the fractional function as a combination of different fractions with different constants. If we have a1x plus b1 to power r, this means we are going to have r different constants. a1, a2 up to a sub r for that factor. So it would be a1 divided by a1x plus, or capital A with small a1x plus b1. This is for the power 1. For the second power, we have a2 or capital A2 up to half power. We have capital A sub r. So any factors with repeated 0 or with multiplicity r, we have to write it as combination of r fractions. For example, for that we need to evaluate this fractional function x squared plus x plus 1 divided by x plus 1 to power 2, x plus 2. You can see that x plus 1 is a linear factor, but with multiplicity 2 or with power 2. If this is like, you can write it as function divided by x plus 1 multiplied by x plus 1 because it's repeated 2 times multiplied by x plus 2. So it is, we have 3 factors. So we can write it as a1 divided by x plus 1 for the first one, plus a2 for x plus 1 for the second one, but that should be to power 2, plus a3 divided by x plus 2. So the idea is to write 3 fractions because I have 3 factors in the denominator. Since we have 3 factors, we can write 3 fractions. So x squared plus x plus 1, that is x squared plus x plus 1 divided by x plus 1 square multiplied by x plus 2 is equal to, the first one is a, I will use different letters a, b, and c for the 3 factors. A divided by x plus 1 plus, for the second one, which is power 2, we'll have b divided by x plus 1 to power 2 plus, for the third one, it is c divided by x plus 2. Now I need to find the values for these constants a, b, and c. As we did in the first part, if we multiply the equation by the denominator, multiply by this denominator, we will have x squared plus x plus 1 equal to a times. This x plus 1 will cancel 1 of the power. So it will be a multiplied by x plus 2. So x plus 1 times x plus 2. For the second fraction, this square will cancel the whole x plus 1 all to the power 2. So it will be plus b multiplied by x plus 2. For the constant c, we'll cancel x plus 2 with x plus 2. So the remaining will be x plus 1 to power 2. This will be plus c multiplied by x plus 1 to power 2. Now I have equation. We have two methods to find this constant a, b, and c. The first one, we can open the brackets and we equate the coefficient on the left and on the right. So the coefficient of x squared on the left will be the or equal to the coefficient of x squared in the right hand side, and coefficient of x in the left hand side will be equal to the coefficient of x in the right hand side, and like this. Or we can do values for x so that we can terminate one of these factors. For example, if we choose x to be minus 1, for example, let x equal to minus 1. So let's replace x by minus 1. If x equal to minus 1, this will be 0, and this will be 0. So only I will have b. So replacing x by minus 1, I will get minus 1 square plus minus 1 plus 1 equal to b multiplied by minus 1 plus 2. This will give me, solve it, I will have b equal to 1. So we found b. For a and c. Now, let me choose x equal to minus 2 for this case. X now let x equal to minus 2. If x equal to minus 2, this will be 0, and this will be 0. So I'll have minus 2 to power 2 minus 2 plus 1 equal to 3 multiplied by minus 2 plus 1 all to power. I'll have 5 minus 2 is equal to 3. On the left hand side, 3 equal to minus 2 plus 1 is minus 1 to power 2 is equal to 1. So it is c, only c times 1. So c equal to c. Now we found b and we found c. To find a, we can choose x any value now. And to make it easy, we can choose x equal to 0. Because this is an identity, which means it is true for any value for x. So if we choose x equal to 0, let x equal to 0. So the left hand side is equal to 1. Equal to. This is 0. This is 0. It's equal to 1. This is 0. X will be removed. And also, this is will be 0, and this is equal to 0. So I will have 1 on the left hand side equal to a multiplied by 1 times 2 plus b times 2 plus c times 1. If I'm going to see it, I will have only the constants 1, 2, and 2, and 1 to power 1. I'm sorry, to power 2. So this is equal to 1 equal to 2a plus we have b equal to 1 and c equal to 3. So this will be 2 multiplied by 1 plus 3. So it is 1 equal to a plus 5, or 2a equal to minus 4. This will give me a equal to minus 2. So I have a, b, and c. So the integration, again, which is from 0 to 1, of x squared plus x plus 1 divided by square x plus 2 dx is equal to the integration from 0 to 1, a equal to minus 2 divided by x plus 1 plus b, which is equal to 1 over x plus 1 to power 2 plus c, which is equal to 3 divided by x plus 2 dx. The integration for the first one is equal to minus 2 ln of x plus 1, or absolute value of x plus 1. Integration of 1 over x1, x plus 1, or to power 2, this is just reverse the quotient rule for the derivatives. It will give me minus 1 divided by x plus 1. And the third one is equal to 3 multiplied by ln of x plus 2 from 0 to 1. Now we need to evaluate it by replacing x by 1, then by 0. So this is equal to minus 2. We replace x by 1, minus 2. Minus 1 over 2 plus 3 ln of 3. Minus, now replace it by 0, will be, sit down. This is minus 2 ln of 1 minus 1 over 1, which is equal to 1 plus 3 ln of 2. This is equal to 0. Minus 1 with minus 5 is equal to 1/2. So we will have, karate in general, this is equal to minus 2 with minus 3 is minus 5. Ln of 2 plus 3 ln of 3, and minus half plus 1 is equal to plus 1/2. So this is the value of the given integral. The idea is just to write it as partial fractions, then we find the integration for each part.